Hello guys, today I want to introduce my new machines that incorporates, explains the stuff that incorporates the tool changing boxes, and it's a electrical ones, and the machine is made from German, and I DIY. I made this barrel touch cover, and also I DIY a touch box here. This is a electrical one, wireless. This is the receiving box, and also I made the interface myself. All these stuff were done 6 years ago, and at that time it is not fully completed. At that time I do my another machines. This is my latest one, the largest new machine. And during these half years, I go on this auto tool changing operations, and I now finished it. I explained this today. Firstly, I need to have a better control box. It was upgraded from the original one. Inside I will have some pictures to show that they incorporated a Ethernet smooth stepper that have 15-1 input and output, so it's enough for my use. You can see here, these two socket is for the tool changing box, and if I connect the VFD spindle, I also can use this socket to control its operation. There's two sockets for the extra 4th and 5th axis. And another hardware is this electrical operators two boxes. It is 5 2 pulses. There are two. You can see here. There is this. This is the resetter, and there is a hard surface here. So the purpose of it is to, let me explain. Is obviously this reset tool has a setter is for this use. Pop it and have the two length values for compensations, and because I use this touch board to touch the workpiece surface, I need to have the relationships between those two things. There is the there's this surface and the ball of the pop surface, because this have a truffle. You can see when touch, it truffle a certain amount before it was chipped. So these two surfaces, this and this surface, when this is pressed down, the surfaces are in level. So it means that they are the same height. This surface on this surface height is same height as this ball touch with this hard surface. So they are related, and then have the correct values for the tool length compensations for this surface. And of course there are, beside this vertical truffle, there is side operation, and there are 4 small set screws there, 1, 2, 3, 4, for setting the centering of this post. But I didn't use it, and I have another method to compensation for this vertical position or the errors. And this is the wireless, and the very small 3 pieces of button cell is put inside from the top. You can see this cap can be screwed out. And also there is set screw on this under this T-slot, and it will set the chipped length before it was set the deviation amounts before it was chipped. You can see. And because this is in my new design that is different from the designs on the market, on the existing pops, on the touch pops on the market. It needs small amount of truffle before it was chipped. So I need the calibrations procedures to know this amount of chip distance on 4 directions, and have these values for stored in the memories for use for compensation. And later on the codes or programs will be explained briefly. And this is inside there is the electronic components for, besides the mechanical one, also have the electronic components for wireless transmissions. I have another video previously posted on the YouTube to explain all the stuff of the electronic aspects of these things. And this is the receiver, wireless receiver, and you can see there is a small red wire here as a antenna. Of course there are hidden antenna here, and this is the let me explain. And okay, is all the hardware needed in order to do the things. And another one is the software. Of course I need the Mark III software, and I downloaded this 5-axis software made by this Uber factory. is free downloaders at that time. I don't know whether it's now. It's very good and beautiful made interface. It also have some touch operations, but I never use it because I don't accustomed to I'm not accustomed to use those things because no one explained to me. Anyway, I made this one by myself. There are 2 pages, 1 and 2 for the extra operations. You can see here these pages, 2 changes, and this is 1, 2, 3, 4, 5 is 5 2 pocket. This light is not lamp turn on. All 4 is on because there are tools inserted. You can see here. I bring out this touch port here. One thing is that in market the touch port is bigger in diameter. I do not like it, so I DIY this one. Is slimmer. I think this is around 12 to 15 millimeter in diameter that can put into the pocket. So when no tools, it will sense. So there is sensor there, light sensor inside this pocket to give the informations if the tool are correctly inserted or picked up. Otherwise it will stop or continues the operation. And to do this new interface, one more thing in the second pages here, this is for touch port operation. This you can see there are more complicated, and I have included some diagram to explain the work data corresponding to work areas. And here there is also a diagram. In order to make these 2 pages and make it operators, you need to know how to do it in Mark 3. And here is my Mark 3 directory, and you need to have the screen 4. This is for making the user interface, graphic user interface. And when this is hit and it bring out this software and open one of this existing interface. This one is the basic one, and this one is the current. When I hit it, you open the current, and then you can change it. Or at first times there is no these 2 pages I added, and do all the stuff there. So you need to know how to do it, and there is some information for or you need to know and to take those information to read. Let me go to another directory. March document, you can see here. This is my library. It contains some PDF document. All this can be downloaded from the internet. So after reading through all this, you know how to program and make the interface. And here, operator, we hit this. There's something you can use. Brain control. When you hit this, I add a new brain control here. Brain OEM trigger. You can see this one. This one is my new address. So if I hit this VB editor and open, and you can see this thing, brain. Yeah, there's no. Okay, it should be open under this button, brain editor. Okay, and open, and then you can open a new file and do the coding. And now I open my old file, and in order to link some OEM trigger to OEM, you can see here OEM LED. You need to do this file. You have to make this file. This is needed in here, not here. Here, OEM code. So there are a number of codes. It includes this 5 sensor and other sensor, such as operating the door open of the toolbox, this door. I first made this toolchanging box interface and program, and this here. And edit the button, use this edit button script, and then each button will have the number 1 M code, M6 T1 code, this M6 T2 extra, etc. to number 5. This button also I allocated the number T0, M6 T6, M6 T7, and M6 T8. So each button can activate the individual M6 code, and now I bring the program code. First, you need to have modify the M6 star code, and here you can also see another is Marco Pom. So in my operations, I included the use of the M6 code operation and a small Marco code, and the Marco code is used for this button to hit, and I will later on explain this one. First, I explain the toolchanging code, and before I see there are many programs. And before I don't separate this several individual program code, in this M star code I just include one large program here is 99997. It includes all the operations, there is all the tool changings and the touch operation, and it's a very long programs and almost 4,000 lines of codes. Later on I break it down and break it to several programs. So when each button hit, for example, when 20 is hit, is for return the 2 to pocket. So it will call code 9990. If number 1 to number 5, there is M6T1 to M6T5 was integrated. This integration is by pressing the button here, touching it, and you can see I will open this active button script. So when I hit this, so when I hit this LED light is turned on. This light is turned on, and T2 number 2 is this code is integrated. Another lamp is turned off. Otherwise, do the operations opposites. So it will call the program 9991, and in before is to return to pocket is 9990, this one, and this is the shortness program. 9991 is selecting the 5 tools. It's not a long program. Okay, if number 6 or the M6T6 is hidden, is 9993. it will do the pop calibrations operation. It includes two operations. And before I explained the needs of these truffles. Before it was shipped, this truffle information need to be got, and those values will be put in these four boxes. They are corresponding to x, y direction in positive and negative directions. So there are four values. So during the calibrations, this touch pop will hit four sides of this reference rectangular box. And I need to explain first. The first operation is to hold my machines first in 3 directions. Then I will insert these dial indicators into the spindle, and this indicator this circle is true circle, and then I need to move the position of the Z head with this touch pop, with this dial indicator almost at center, and then by turning this dial indicator until this pointers in 4 directions is same. That means the spindle is at center position of this circle. Then I have this value, xy value, to enter this box here. You can see here is circles, and this is a calibration box. I enter the value. Currently is x and y is this two value. This is input 1. So hitting this operation, pop calibrations, after I do mechanical manually by me, it has this value, and also I enter the true circle diameter is 16, and internally it has this length, as I remember, is 22. This is around 13 or something in width. So it has the position of each x, y plus and minus value of this rectangular box. As well, it has the value of this 4 corner. Currently is here, 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 here. So after this manually settled, then I will do these operations by hitting this 1 and 2 calibration. In the one operation in calibrations, this touch port will touch 4 sides of this reference box and have its xy value, and it will compare internally the true values, and then have the differences to put here. This 4 box currently x, y plus minus have this value, enter, and in doing so it also shows us the measure one. There's I have no this one, this is 0. I just only 4 sides. There is the positive x, this is the minus X and Y direction, you can see here, and the other box is left 0, have not do anything there, as well as the Y plus and Y minus. So these are measured, and so it will calculate the deviations. That's the over truffle deviation, or you can call it as a compensation value. And afterwards, in second operation, here is second operation. It will ask you if it is continuous. If it continuous, it will continue to touch poke the circle center, touch poke 4 sides of the circle to find the circle center. And in doing so, it will ask if you use these deviation values to incorporation into the measure value. So I accepted to use, and then it come out the measure this center is this value. So you can side by side to see the differences is very small, 0.02 in X, 0.04 in Y. So this value is reliable. Then it finish all the calibration work, and I will do this whenever I need to touch poke of the workpiece. So it's not one-time calibration work, because whenever this longest pieces touch poke mounted on the spindle, and also this have the direction, the XY direction will change it will rotate, so it's not same at different times. So different times you need to calibrate once, then the compensation value will cancel out all the errors in alignments in these directions, then precisions can be get. So once the calibration work is done, that I will touch these buttons to do the regular popping words, and then it will go to these pages. There is a lot of options for me to choose, and for here, this is a rectangular workpieces. At first time I need to touch this reference surface first, and then I will move to this workpiece surface to touch this surface. So I will get this difference, this height difference from this 2 setter height to this, and have this value. And when I do the tooling compensations, I will incorporate this value, so I can set this surface as 0. So this is the first operations of doing the touch poke. And then for this workpiece, I have different options to touch. If I found the center that is normally do the machining work, I will touch the 4 sides, and then get the center. If I want just to do either side or just do the center of Y direction or just do center of X direction, I have options to choose. Also, if I do want to find this corner, touch this corner, touch this, and the string. And also, if there are rectangular hole, if this is rectangular internal hole, I have option to choose. If I have circular pieces, I can touch the circular outer shape surface. If internal, I can touch internal workpiece. All these options I can choose in this interface. So this long length of coding is to do this. And here the first button is choose the different shape of workpiece, rectangular, circular, or for finding the edge corner, you can see here this light is turned on upper right. If I continue to hit this button, it will change to lower right and turn off. Again, it will shift to this. So I have this, and the second one is type of popping. The first one is the basic popping reference recess. There's this touched here, and second is manual popping workpiece reset on wide truck platform. Firstly, I have 2 or 3 works offset currently. I can choose currently normal. I will use number 1. That's wise. Wise is here. So if I put on a truck, circular truck, such this thing here, I put on here. I have another work offset here, truck to choose. If I put on a platform here, this is the aluminum platform on top here. I can choose here. Number 3, 2, 1. So here, manually popping workpiece reset on wise truck and platform. If here is on wise, so wise normally have the center in X direction. In my machine here is X direction, so it recorded the X directions here and have information, and I put on here. The Y's have the center XY here. If I have the truck here, I will insert the center location here, and then it will pop this the workpiece surface. So I don't need to input further information on this roughly position. The the most important things I need is, if not get current DRO before, need to quit and do so. So I need to move to get the DRO first. I use this button and then bring the spindle here and to some places here or something here, and I need to know this XY position. I either read this value or just hit this button, and hit this button is what I need the program. Here is the macro program. Sorry, this I write this macro program for it to run. This is the line of code. I don't explain detailing. So when the spindle or touch probe is up above the workpiece surface some position, I hit this. The last record one is here, so I need to cancel it first. Hit this button, so it will turn 0. So when the spindle is above the workpiece surface, I hit this again. Currently it is in this position. So I hit this. Oh, I haven't home the machine. For example, I just move the machines a little bit. So it's in this position, the spindle. I hit this, it will get the current, this current values stored. I hit this, so this value, these two value is stored in these two DRO. Then have this DRO, then I continues the operation. When this is choose, and this choose now is rectangular box, and is for outer, not the inner. When this two button is choose, when I go back to this here and I hit this top regular, then it will take the touch probe and do the touch operation here and get this surface position. That is number 9 and 10, these two value. Lastly, it was stored this two value. 9 is here, this value for later use. And if I choose next one, auto touch probe workpiece is set on wise, then I don't need to have this information. If this is a flat surface and it have this roughly center position, because I will input this workpiece length here is now 14 feet by 14 feet, so it will have the roughly center position. When I hit this button, it will do auto popping workpiece is set on once. Then I just hit this, and oh sorry, I need to enter the roughly height value. That is, I need to number 10. No, let me explain this. and I need to input something first. In order to make this happen, there's auto popping. I have the workpiece height and the support. There's parallel bar. There's set about number 8. I need to input this number 8, this value, and I have marked this simple. This is menu input value. This is measure value. This is auto get if button hit or input manually. This start, this one. Menu input is this one. So I input 49.5. That is from this bottom to this surface. I can use calibrator to enter this value and have this value. I just hit this button. It will do the auto popping on the surface of the workpiece. And if I go on to next one, this will find the center and will have workpiece XY. As I explain first, X and Y, and then it will calculate the center and will enter the center on these two boxes. Currently is the last one is this value. If I just do the X direction, Y direction, just this. So if this is now corresponds to for the workpiece shape, rectangular workpiece and outers, I can do the inner for this. If this is inner, it will touch inside diameter, inside value, move in this here, knock the outer with circles. It will touch inside circle instead of outer circle. Of course, in the programs, you see in the programs, you need to take care many stuff in the program. Here the program. So you can see here in different shapes there is plus and minus values for different options. Yes. And so continue, it will circular, inner, finally to edge corner, 4 edges. So we will do and in doing edge corner, because I have this value, this over truffle value. So after touching, it will subtract or includes the truffles, then find the actual value of the center of the corner. So it will get the actual value, not the bisected of the center. On this side here, this is the diameter of the spear of the ball of the touch pop is 5.5 mm in diameter. Approximately is a pop reference. This is the number 3 and 4, and this one is my input one, minus 22. I need to input this number 3. So we have the rough value first to let the touch pop go down. Number 4 is the the touch value. This will touch here, both for the reset setter and the tool and the touch pop reference surface use. And this portion is not used now, and is for fifth axis use when the fifth axis I have the truck on it. When it turned down by 19 degrees, we took some offset and compensation here. I have not used here. Although the program include, I have not used it. And go back to these pages, there are some value to be input into this dial box. Here, feed rate override feed rate now is 113. Locking time, unlocking time. This corresponding to when the tools are turning to lock on the spindle or unlocking, there is time to be input and adjust here. I put the time in 13 seconds, something 15 seconds, and also in setting of the machines or the toolbox, I need the toolbox position. I need to, this one is center of two boxes, X, Y. This X and Y's. Reset of toolbox H values is number 5. You see this is number 5 from collar bottom to this surface. So if all those values inputs, I don't need to take care of it. Furthermore, every time I just need to do calibration, and you find the center or the corner values. And there is one more button is here, number 7. This is just do the pop calibration number 2. That's to find the center. It's not very often used. It's just an additional one. So this will end the first part of this episodes. In next part, I will do some wheel operations or cuttings. There's the demonstration. Thank you for your watching.